Page 14, we did the last. That was page 14. Now, page 15. Explain in terms of the molecules why it is possible to compress a gas but not a liquid. Yes. Why we can compress a gas but not a liquid. Yeah, so gas molecules are far apart or they have large spacing where molecules in a liquid are actually touching each other. So you cannot, one mark gas molecules are far apart, that is right. And the second thing, the molecules of a liquid molecules are touching each other. That's the difference. So if you check the marking scheme here at the end of the question, so gas molecules are far and liquid very close is right, and compact or they are touching each other. So you can mention any of them. The next is two containers which are made of insulating material contain the same volume of a water at room temperature. The containers do not have lids. The volume of a liquid in each container gradually decreases. After a certain time, the temperature of a water has decreased below the room temperature. Explain in terms of molecule why the temperature has decreased. Why the temperature has decreased. So which process happened or occurred? Evaporation. Because because of evaporation, the most energetic molecules they gain energy and they leave the liquid surface. So the molecules which are left behind due to evaporation, where most energetic particles escape, so less energetic particles are left behind. That's why it will cool down. One of the container is wide and shallow, and the other container is narrow and deep. Predict which container will have a greater rate of cooling, like which will cool down faster or which will have a greater. So wide and narrow, not it cannot be. It either it is wide and shallow or it is narrow and deep. So it should be wide and shallow. And why wide and shallow? Because greater number of the particles are exposed to the surrounding. State what happened to the molecule of a gas in a sealed container when the temperature of a gas increases. When we increase the temperature of a gas, what we'll observe? So their kinetic energy will increase or they will move faster. So it will increase the kinetic energy, or you can also say increase the speed, or you can say they will move faster. A quantity of a gas is contained in a sealed container with a fixed volume. So volume is not changing. The temperature of a gas increase. State in terms of molecule two reason why the pressure of a gas increases. We have a sealed container. A container is sealed. When we say sealed container, volume cannot change. Why the pressure increases? So yeah, that is right. That's how they exert pressure. But why the pressure increase? They move or more collisions per second, or they will hit the wall hard, like exerting more force. So exert greater force, or they will collide off. Or more molecules collide in 1 second, or collision frequency increases. You can also say that. The next part, a helium-filled weather balloon is held at a ground level where the volume is 4,800 meter cube. So that is the initial volume. And the pressure is 98 kilopascal. So that is the first pressure. The balloon is released and it rises to a height where the volume of the balloon is 7,200. Calculate a new pressure, assume that the temperature remains constant. So we have to use a Boyle's law. According to that, P1 V1 equals P2 V2. When temperature is constant, the product of initial pressure and initial volume will be equals to final pressure and final volume. So that is 98. You're not supposed, like if I'm not converting kilopascal into pascal, I can write my final answer in kilopascal as well. So 98 into 4,800, new pressure we don't know, and this was 7,200. This will be multiplied, other side divide, so 98 times 4,800 divided by 7,200. Which answer? Three significant figures. So 65.3 kilopascal. Usually the marking scheme answers are rounded up to 2 or 3, but you should always write answer in 3 but don't write in. No, they don't mention that, but the standard rule for it's 3 significant figures. So always write your answer in 3 Suggests why it may be necessary to release the helium from a balloon as it even rises higher. Like, look, as you can see on the surface, when this was released, the balloon was released, it was having a volume of 4,800. But when it rises to a higher altitude, the volume has increased to 7,200. Means it get larger, 7,200. So why we should remove some of the helium out from this balloon as it is rising? So the balloon might burst because inside pressure will be higher than the outside pressure. So the balloon may burst due to greater pressure from inside compared to outside. So that's why we should remove some of the gas so that it balances with the outward pressure.